Good morning all and welcome, good afternoon. Welcome to Python Coding Lesson 12. Today's lesson will be doing indexing and error catching. And a quick reminder for those of y'all that missed it previously, if y'all could please make sure that y'all go to the Google Docs drive, and I'll post the link in chat and fill out the contact information so that y'all can get your your certificates at the end of this entire thing. So here's the Google's doc drive document that you'll be filling out. I'll be posting the link in chat once again. Please make sure that y'all fill it out or get your parents to fill it out for y'all. All right. Okay, so on to today's lesson. Before we go on to any further, let's have a quick recap of the work we have actually done so far or from yesterday. So from yesterday's work, we learned that we can insert items into a list by using the list.insert function. Now remember, the .insert part allows us to insert information. And when we insert information into a list, the information gets stored in the last position. So whenever when we use this, we tell it what position we want to enter it in, and then we tell it the item position. So if I tell it position 1 and I give it an item to put in, whether it's a number or a text, it'll go to that position, position 1, it'll insert the information at that position, and everything that was there previously will move 1 to the right. So our entire list now increases by 1. Then we learned that we have removing an item from a list, and in order to remove an item from the list, we just say list.remove and we give it the item's name. And we learned that when it removes the item from the list, it actually removes the first occurrence. First occurrence means the first time it comes across it. So if there was duplicate items in this list that we have, it'll only remove the first position that it comes across. After that, we went to list.pop and we said the pop part of it allows us to remove a specific item at a position. So we can tell the computer to remove item 1 or item 2 or item 3, and it'll remove that item from that list. Now, pay careful attention when we use the pop function as well. We use round brackets and not square. If you use square brackets there, it's going to give you an error. Then as well as attaching to this pop function, we have that if no index is given, then the index -1 is used, and -1 by default means the last item is removed. Remember, -1 meaning the last position, -2, second last position, because the list now has both positive and negative positions. If you start counting from the front, we start at 0, and if we start from the back of the list, it starts off at -1. And lastly, we did the clear list. The clear list one was just list.clear, and this allowed us to remove any items that was in the list. So making sure that the list is now blank when we want to use it. After that, we went on to the activity, and the first activity was to write a program to find, or that will find the sum of all the items in a given list entered by the user. We did that one there. And write a program to find and display the largest number in a given list. I did that one there with y'all. I said these two over here was for you to try, and we'll answer it today. So let's look at this one here. write a program to display the sum, difference, product, quotient of a given list entered by the user. So let's open up a program to work with that. Quickly open up Python. And we're going to go File, New File. And we're going to look at the question and break the question down before we actually answer it. So if we look at the question again, what do we need to do? We need to write a program to display the sum, the difference, the product, and the quotient of a given list. That means the list has to be given to us. And this list is being given to us by the user. So if we look at what is going to be our input in this case is going to be what is given. So what is being given? All the numbers. So that list is being given. So I need to enter in, or I need to create a variable for numbers, and I need to input it. And the question becomes, do we know how many numbers we are going to be entering? And to answer the question, no, we don't know how many numbers we're going to be entering. So we have to use a while loop. So if we're using a while loop to do this, we're going to firstly go back, file, save, so 12, sum, difference, products, and quotient. Right. So we're going to now program this. Now, if you remember carefully from our programs previously, we have to make sure that we are going to say, all right, what are we going to be importing? Or if we importing anything, then what is our functions that we're going to be creating? And finally, our main program. And if I look at this, am I going to be importing anything here? So the only time we learned the import statement so far was when we used the math module and when we use the random module. And in this case over here, we're not going to find the square root of numbers and so on. So we're not going to use the math module. The random module we're not going to be using because we're not generating random numbers. The user is going to enter the numbers for us. So we're not going to import anything. But for functions, yes, we're going to be writing in functions. And the first function we'll be writing is the function to enter in a number or enter in the numbers. So before I can write that function out, let's create our variables to store this function. So the first variable we're going to have is list of numbers. So if I have list of numbers and I'm going to equal it to square brackets, because remember, square brackets means it's going to be a list. Now, once I have this, I can now work with my definition because I have a variable to store it in. So I'm going to go defining a function, and this is going to be input numbers. And it's going to receive the list of numbers. Now you see, again, we only receive variables that we want to make changes to. So I want to change this variable, so I'm going to receive it. If I don't put it in here, it will, it will not change it. It'll be like the previous programs that we did at the start, where the functions don't change our variables. Right. So now I've got the function. I can now give a user the input. So I can say print enter in minus 99 to stop. On the next line, just going to put in lines. Right. On my next line now, I can say, okay, so the number that I'm going to get, now again, this is going to be a number. And if we're using an input to get the number, we'll need to convert it. So I'm going to say enter in a number. So because this input is always going to be giving you string, and we want to do some calculations with this number later on, we're going to make sure that this number that we enter is going to be a integer or float. So I'm going to go make it an integer for the time being. All right. The next thing we're going to do is we're going to make sure that this list is cleared. I don't want anything in it. So I'm going to quickly go and say list numbers dot clear, just to make use of that list function as well. Right. So now I cleared it. I can now start entering information into it. So I can say, okay, while the number the person had entered is not equal to minus 99, I want to do some work. And what is the work that I want to do? If we looked at the question again quickly, the work is we need to make sure that the person enters in the numbers. That's what we test in over here. Remember, we initialized it at the start here. Let me put it closer so you can see it. So on this line, I'll put it here. We initialize the number. We got the person to enter it. Now we test in, is this number that the person entered here in line 7 not equal to minus 99? And if it's not equal to minus 99, then what am I going to do? I'm going to first add the number to the list. So I'm going to go list numbers dot append. And what does the append do again? Yes, it adds it to the end of the list. So if there's nothing in the list, it'll add it to the end. So it becomes the first item. Then it becomes second item, third item. After that, it continues in that pattern. So I'm going to add the number. Now, if I decide to run the program at this point, and if I call up the input numbers, I'm going to be stuck in an infinite loop. And the reason for this is because we forgot to do one thing in the while loop. And I'm going to show you this. Input numbers. And again, input numbers is telling me I need to make sure I send it a variable. And the variable I'm going to send it is list numbers. Now what this does again, it links the variable in the main program to the variable in the function. So now whatever changes you do to this variable in this function changes the variable on the outside. All right. So now if I call this up and I show you what I mean by it'll do an infinite loop. So it'll ask me to enter a number. And if I don't enter minus 99, if I enter 90, you'll see that the computer just blinks on. The computer is blinking on over here. It's not asking me for another number because, yes, for those of you that got it, we didn't do the change part. Always remember that the while loop requires you to initialize, test, and then change on the inside. So we're going to change the number on the inside because we test in the number. So we'll say on the inside for the person to enter a new number. And now that the person enters a new number, we are now changing that number. So eventually when the person does decide they're done with our entry numbers, they can enter minus 99 and stop. So now if we run it, I can enter in numbers 79, 56, 34, and I can continuously enter numbers and it won't stop until I reach minus 99 or until I enter minus 99. There you go, it stopped. Got the end of the code. All right. So now we've got the input. The next part is the processing. So if we look at our quick question again, question. So now we got our input, we're going to go to our processing. Our processing is we need to calculate sum, difference, product, quotient of the given list. So when I'm calculating the sum, that list is going to be given to the function. When I'm calculating difference, again, the list is going to be given to the difference function. So we're going to calculate functions for each one of the following. So quickly, I'm going to go back to that program and we're going to call up our first one. So I'm going to say define. I'm going to go with sum. And this time, I'm not going to be sending any information to the sum function that I'm creating. And the reason I'm not sending anything to the sum function I'm creating is because I'm not going to be changing the list. I'm still using that normal list. So if I don't send it through, the sum function can't change it. But because it's already been created in the main program, I can still use it. So that's the difference now. When you don't send information through, but you use the variable, you can use it, but it won't change anything, right? So I go sum equal to, oh, I can't use small s. Actually, I'm going to use capital S, right? Sum, the reason again why I couldn't use small s, because that's sum over here, you look, it's pink, and that means it's a function. So I can't use that as a variable. That's why I'm going to go with capital S. That's why, as well as my function name is not with small s. All right, so I'm going to go capital S sum is equal to 0. I'm calculating the sum, so I'm going to start off at a 0 position. Then I'm going to go, right, how big is this list that I've got? So I'm going to go find the length of the list. And when I find the length of the list, I use the length function. So I go length, and I find inside it the length of the list. And the length of the list is called list numbers. So I'm just going to copy it from there and paste it. For some of y'all that's still confused how I'm using list numbers here when it's not been sent, again, it's created outside in my main program. But because it's not being sent to the sum function can't change anything inside list, but it can still use it. So variables can still be used, but they won't be changed. Right. So I'm going to continue. Say, right, I'm going to run a for loop. So for, and I'm just going to go with I instead of count, just for a short form version. So I'm going to go I in range. I'm going to say, how big is this list? The length of the list is stored in length underscore list. Now this variable I, remember previously I was putting count. I'm just putting short form now so that we can use it in our program. But it's doing the same thing as count. Okay, so now I can say, okay, sum plus equals to list of numbers at position I. Previously, I would have put position count. But remember, I is doing the same thing as what count did. It's counting from 0 till the length of the list. Just a shorter way of putting variables, right? And then finally, I can go print the sum is comma sum. Now that I'm done with the sum function, I can test whether it's working. How I test it? By just calling it up. So I'm calling it up. Notice there's nothing in brackets because sum doesn't require me to put anything in brackets. But if I run it now, I'm going to run it. I'm going to put 2, 4, 6, and we know that 2, 4, 6 will give us 12. So I'm going to put minus 99, and I put something incorrect. What was it? List number. Okay, I spelled it incorrect. Not number, numbers. Remember, it must, if it's going to be the outside variable, let's make sure I put the spelling correctly. Right, let's try it one more time. 246 minus 99. There we go. The sum is 12. So I've got my sum program down. Now the next part is to do it for the subtraction, multiplication, and the quotient. So now I'm going to simply copy and paste it and make some adjustments, because that's what coding is. If it's going to be something similar, then we should just copy and paste and make adjustments accordingly. So there we go. So now instead of doing the sum part of it, I'm going to do subtraction. And of course, for subtraction, I'm not calculating sum anymore, so I'll put there subtraction. And it's not going to be plus equal to, it's going to be minus equal to. Now all this is going to do, it's going to do the opposite of what the sum program did. The sum program added all the numbers. This is going to subtract all the numbers. Just going to put a separator here so you can see that the definitions are all separated. Otherwise, it looks like it's all one big program. Right. So there's my subtraction one here. So now I can simply change that as well to subtraction. I can say the difference is, and put down subtraction. I need to change that one there as well. All the variables. So these are the small changes that we make into the method or the function that we run in. Then finally, I can put down sub, run it. 246 minus 99. There we go. The sum is 12, the difference is minus 12. So if we add all the numbers, you get 12. Subtract all the numbers from each other, you get minus 12. Of course, we got minus 12 because remember the first number we stored in sum was 0, right? Not 2. So it's at 0 minus 2 minus 4 minus 6. Again, copy the entire thing. Paste it. Make some small adjustments. Now we just want multiplication. So I'm going to change that to mul. Change this as well. We go products. So if that's changing to product, wherever I got subtraction, I need to put product as well. Okay, the product is product, and it's no more subtraction equal to, it's multiplication equal to. Now we can quickly run it. So we're going to go multiplication, open and round brackets, and run it. So now we go 246 minus 99, and small m. Right, I put small m, I need to put capital M. Again, mistakes happen. You just have to be able to read what the mistakes was. 246 minus 99. And the answer is 0. Can any of you guess why the answer is 0? For those of you all that saw, yes, I put product is equal to 0. And we all know that 0 times any number is 0. So we can't start off a product with 0. So what do we start it off with? Yes, for those of you that said 1, we start it with 1. Because just like how we know 0 times any number is 0, we know that if we take any number and times it by 1, it'll be that any number we started with. So if I say 2 times 1, it'll be 2. If I say 3 times 1, it'll be 3. If I say 25 times 1, still 25. It's at any number. So now we have a working product. 246 minus 99. There you go. 48 is the answer. Finally, we go on to the quotient. So if I'm going to do the quotient one again, copy, paste. Ooh, that went in. That's not supposed to go in there. It's supposed to be there. All right, so now I can go with quotient. QUO. Copy, put it in product, put it in product, product. All right, I'm just going to put quotient there like that. And that becomes our program, except it's not times, it's divide. Now remember, this was all short forms. It just means take that and divide it by that, right? Next, I can run the program, quotient. And yes, I'm going to leave it at 1 because I can't put it back to 0. Because if you take 0 and divide it by any number, you're going to get an error, which is why it's you're going to get 0. 0 division is undefined. Right, so if you're going to get 0, if you take 0 divided by any number, that's what we start off with, 1. So there we go. 246 minus 99. And there's our answers. So that was the program for the sum, difference, and quotient. Okay, so then we went on and I told you, you had to write a program to find and display the smallest of the numbers in a given list. So in order to do this program, I'm going to quickly open up our older program, which was the maximum number from yesterday's work. All right. And I'm going to change this program to reflect the maximum, minimum. So I'm going to quickly save as lesson 12, minimum number. All right. So again, we've got everything already there for us. So we're going to make some small changes. The small changes is we're not going to find the maximum number. We're going to find the minimum number. So I'm going to take out max. I'm going to put min. And that needs to come out. Min is empty. The next thing, I don't want the maximum value. Again, it is minimum value. So wherever I see max, I'm going to put min. It's just variable names, but it makes sense to change them to reflect what we want to do. Smallest number is minimum value. And the only thing we do is in our if condition, we change it. Remember, we were testing if this value was smaller before. So now we test if it's bigger. And that becomes our program. Yeah, I know it's a bit confusing that when you check in minimum, you check in greater than, when you go in maximum, you check in less than, but it's just the condition that you're looking for. So if I got 23, 4, 5, 89, 0, 7, 11, minus 22, 33, 44, 55, 90, 100, and then go minus 99. We all know that the smallest number here should be minus 22. So I go there, I broke. Name list is not defined. The variable name I incorrect. So I have to quickly go and put that. This should have been list of numbers. So here's it here. That should fix our program. Okay, I'm just going to enter quickly some numbers, and I entered blank. Sorry about that. Minus 2, and minus 2 should be our answer. Again, main value. See, I spelled it wrong. So again, the hardest part of this programming is Let's make sure that your spelling everything is correct. Main value. Right, main value. There we go. Minus 67 is our smallest value. Those of you who maybe say, but sir, minus 99 is there. No, minus 99 is there to tell us to stop, so it's not counted as part of our numbers. So if a person had to enter minus 99, it'll automatically stop taking numbers. All right. So that would have been our minimum program. Then now to go on to today's work. All right, there we go. Oh, wait, before I go on to today's work, I had one more activity in that slide. Yes, right. It was write a program that allows a user to enter 10 marks and into a list and 10 names into a list. And the first thing we had to do, we had to display the names and the marks, display the averages, display the mark, and the learner that got the maximum mark. So this was a program similar to our previous ones, but now we add in more functionality to it. So I'm going to quickly open up a Delphi program, Python program. Keep saying Delphi. And so new. And we're going to be looking at the question to analyze what the question's asking us. So if we look at the question again, where's the question? There, right? So what are we going to be doing? We're going to be entering 10 marks and 10 names into a list. So if we enter information into a list, we can either go the for loop or the while loop. For the for loop, we know how many times. For the while loop, we don't know. So if we look at this question, do we know how many times we're going to enter information? Yes, we know that we're going to enter 10 marks. So we're going to be using the for loop to enter information. Then we look at, after that, what are we going to be doing? We're going to be displaying all the names and the marks. So our processing for next function has to be to display all the names and the marks. Then after that, we're going to display the average of these marks. And we did average programs before. And this, because we did it before, we can just look at it and copy it over. And if we are creating average, our processing is going to be, how do we calculate average? All right, so that will be our processing. Calculating average, then our display will be output there. Then we're going to display the mark of the learner that has the maximum mark. So we're going to display the name and the mark. So first we'll have to find what is the maximum mark. And something just happened. Right. So first we'll have to find what the maximum mark is. After we find the maximum mark, we look at who's got the maximum mark. And when we find the person that got the maximum mark, we will display them. So let's go through that step by step in our program. Right, so file, save. Names and marks. 10 learners. Right, so we're going to be having our import, and if we look at our question, we actually had no imports here. So we're going to go straight to the function part of it, and we're going to have our main program. So our main program, what is it? What's the variables we're going to be using in our program? We'll be using names. Names would be a list. We're going to be using marks. Marks will also be a list. With names and marks being a list, we can now start entering information into our program. So we can go, okay, our first definition is input in the data. And if we input in data, and now I want to make changes to these variables, Because I'm making changes to these variables, I must send them through. If I'm not making changes, I don't have to worry about sending them through. All right, so I got names and marks being sent to me. Why again? Because I'm making changes to it. So I got a for loop for I in range, and we've got 10 people. Uh, I'm just going to put down, let's try it with 3 for the first for the first time. And then after that, if it works with 3, we'd change it to obviously 10. Right, so let's go with 3 first. Names dot append. And we're going to be inputting the person's name. So we're going to say enter in name. And we can be a little fancy here by telling them what, well, okay, let's just put enter in a name. For the time being, marks dot append. Now, if it's a mark, it has to be either an integer or float. So I'm going to be telling it's an integer. So I'm going to convert this input to an integer. So I'm going to say int there. Enter in the mark. So now I got an input for it. So that will be my definition for input. And now I can call it up. So I can say input data, and I need to send it names, and I need to send it marks. Again, why am I sending it names and marks? Because I want the computer to make changes to this variable, or variables in this case. And because it'll make changes to the variables, I have to send it through. Otherwise, the alternate way is, yes, you could have went and put global on the top for the variable names. But then again, making global variables is taking away our control. So try to avoid that as far as possible. Okay, so now we've got the input. We're going to quickly make a display to see if it actually inputted the information. So we're going to create a definition. Just like previously, I'm going to just put in a break line there so you can see the definitions are separated. Not important, it's just for visual aspects. And go display the data. And this time I'm not going to send anything through. Why? Because display is going to just output onto the screen. And if I'm just outputting on the screen, I'm not making changes to names and marks. All right. So I'm not going to send through the variables, but I can still use them. So right, let's use them. I in range, and we'll go 3 again. And I can say print name square brackets I, comma marks square bracket I. Now that that's done, I can quickly call it up. Display data and run it. All right, so if I go Sam 23, Dean 45, Frank 50, oh sorry, Frank 50, there we go. We've got Sam, Dean, and Frank in our list. And you can see it displayed it, yet it wasn't sent through. Why? Because we can display informations from lists or any variables without sending them, but we can't make changes. That means if I wanted to go here and say mark 3 is equal to 4, mark 2 is equal to 4, then the computer won't make changes. Just like our first time when I introduced y'all to functions there. All right, so there we go. We got the display done. Next part, display the average of these numbers. So we're going to calculate average, and we did an average before. I'm just going to create this. So I'm going to go defined. I'm just going to put AVG for average, short form. I'm not going to send it anything. And I'm going to run a for loop. Or let's firstly find the sum of the numbers. So sum is equal to 0 for I in range 3. Sum plus equal to, and that's the wrong sum, capital S. Right. Sum plus equal to the marks. I'm going to quickly take that marks, take down the I from there. And finally, after all that, I can go average equal to sum divided by 3. I'm only using 3 numbers for the time being because I'm going to test if this works. So I can go print the average is comma avg. All right. We call up the method to see if it works. So find avg. Oh no, I didn't put brackets. Frank 30 Dean 20 Sam 10. Unsupported type, built-in method, sum divided by 3. Oh, no, that should be it. Oh, there we go. Can spelling. Capital S. Sam 20 Dean 30 Frank 10. There we go. The average is 20 because it added all the numbers and divided by 3. And this numbers added together, 20, 30, and 10 gives us 60. 60 divided by 3 is 20. So it worked. So later on, we can just convert it to the 10. Once we're done with that, we can now find max mark. Okay, so we're going to find the maximum mark. And the first thing we're going to do is I'm going to automatically set the max mark equal, or max mark equal in the, what is max mark equal in the first mark? Because I don't want to check, I don't want to set it to 0 or anything. I want it to have a mark that's actually in my list. So I put it at position 0. So now I got it at position 0. I can test the rest of them. So I can go for I in range, and I don't start at, I don't just put down 3. I need to put down 1, 3. Why? Because I've already taken the 0, 1 to be the maximum one. So now I want to test whether the first position, second position is bigger than this number. If it's true, I need to swap them around. Okay, so there we go. We can now go and say if the maximum mark is less than the marks in I. That means whatever position it is, so position 1, 2, it'll check. Now why I want to check less than? Because if my maximum mark is less than the mark in the list, that means this maximum mark is not the biggest one. And if this is true, it means this is the biggest one. So that's why we always use the reverse sign. All right, I hope that makes sense to y'all. So if that is true, then the maximum mark must be equal to the marks at position I. So what we said, if this maximum mark I have over here is less than that mark, then that means this mark is not max. So I need to take the maximum mark, and that's what I'm doing here. Then finally, after I find the maximum mark, I'm going to run another loop-in structure. And the reason I'm running the loop-in structure again is because after I find the maximum mark, what happens if two people add the same mark? It means I have two people with the maximum mark. Follow? So I need to display their names. So I go for I in range, and this time I will start and go to 3. So I'm going to start at the first 0 position. And I say, okay, if the maximum mark this time is equal to the marks at position I, what does this mean? It means I found the person with the maximum mark. And when I find the person with the maximum mark, I need to display their name and mark. So I'll say print, and I'll say print the learner with the max mark is marks at position I and names at position I. So whenever it finds the maximum mark, it'll display both these items. So we go with this, enter in a name, 33, 44, and 44 again. So we know that we have two people that has to be displayed. There we go. Oh, I didn't display it. Okay, let's try it one more time. This time I'm gonna display it. All right, so I'm gonna go find. Okay, so I'm just gonna show you all with different numbers. Frank has the maximum one. That's correct. So now if I go one more time, this time I put two numbers that have maximum. It tells me both these learners have the maximum mark. Now that's the reason why we ran the second loop-in structure, to go through all the marks again, and whenever we found the marks equal to the maximum, we displayed both the marks and the names. All right, now the fifth, write a program to generate 6 random numbers. Now that's going to be one for you to try again. I'm going to skip and go on to today's work. All right, so let's go through that. Today's work. And let's erase this, shouldn't be there. Okay, for some reason I got writing on my screen. It's not supposed to be there. Okay, let's go with this. Listing or list indexing. List indexing refers to breaking up lists into smaller slices. This allows us to print or copy information from one list or string to another. So this list indexing we're doing now, it can be used on a list or it can be used on a index. Oh, sorry, it can be used on a string. So depending on what we want to use it, we can input for both. So let's look at how we use it. So our syntax, new underscore list is equal to list end, or we got space, colon after the space, and end position. What this does, it copies from the start to the end. Because we didn't give it a starting position, so the starting position is blank here, but we gave it an end position, it starts from the beginning to the end, it'll copy. And I'll do an example with you just now. Then we've got the list starting position and a blank at the end. So this will copy from the starting position to the end. So why it'll copy to the end? because we didn't tell it when to stop. Just like when we didn't tell it when to start, it started from the beginning. Of course, we got a start position and end position. This will copy information from the start position to the end position. And if we look at example here, now going back to string, because I told we can also use this for string, but you can also imagine this as a list. Each list position is holding a letter. So lists and strings have that in common. So if I tell you, okay, what if I wanted to copy from, and I say now blank here, and I give you 4 here, what Python will do, it'll go, okay, because you didn't give me a starting position, I'm going to start copying from the beginning. But since you told me go right up till 4, I'm going to go right up till 4, not including 4. So that's what this answer will be. It'll be PYTH, and that will be what will be stored in new list. The same way I can go with the next one, I can give it a starting position, start copying from 7. And because there's no end position, it'll copy the rest of the letters. So this statement here will say, okay, where's position 7? Here's position 7 here. I'm going to start copying from position 7. But because you didn't tell me when to stop, because we left it blank, it'll copy everything. So because it copies everything from there, it says is fun. And then finally, I can have a starting position and I can have an end position. So I can tell the computer, okay, start at 3, end at 11. And if I start at 3 and end at 11, remember, whenever we're dealing with lists or strings, the last position is never included. So it's going to start at 3 and it's going to go to 11. So right up to 11, not including 11. So now it gives hon is F. So that's the answer for 3 to 11. So these become our list indexing. So we'll be able to pull out information from a list or copy information from a list. Right. So let's look at how it's used in a list, not a string. So let's look at a list. So if I have list marks is equal to, and I give it 1, 2, 3, 4, 5 numbers, and I say, okay, new marks, list marks, and you can see here, it's blank 3. Blank 3 meant start from the beginning and go to position 3. If I start from the beginning, there's the beginning here, go to position 3, that's 0, 1, 2, and if it's going to go to position 3, it's not going to include 3. Remember, that's position 1, sorry, position 0, 1, 2, 3. And if we look at the answer here, there we go. Original list. And if I pull out 3, that's the answer. Now, if you type that out into Python, it will give you that answer. I'm not going to type it out right now. Of course, with the next example, if I give it a starting position and not tell it when to stop, it means copy from that position till the end. So if I tell it 3 here, it's going to go to position 3. 0, 1, 2, 3. Position 3, it's going to now copy from position 3 onwards because I didn't tell it when to stop. So there we go, 50 and 60. So if we look at the answer here, there we go, 50 and 60. Next example. I got start at 1, stop at 3. So if I look at it, that's 0, that's 1. Oh, that's 0, 1, 2, 3, 4. So we're going to start at 1 and we're going to go up till 3. But the last position is never included. So it's the copy 56 and 23. Now, this helps us to copy out information, make a new list of variables in case I wanted to do some other calculations. Like if I first then I asked you for 5 numbers, then I asked for 3 numbers from that 5, you don't have to generate it again. We can just copy it out, right? So the next thing is we learned that in positions, we don't only work with positive numbers, we can also use negative numbers. So what happens if we start using negative numbers in these positions? And the answer is we can. When using negative numbers, we can copy the ends of the list instead of just the beginning. And we do this by saying list marks and we give it just like before. But if I say -2 here, and I don't tell it when to stop. Remember, what does -2 mean when I use it in a list? It means second last position. So it means second last position. Here's the second last position. So it's going to copy 50. And since I didn't tell it when to stop, copy 50 and 60. There we go. It's copying 50 and 60. Now you may say, but sir, that's the same thing. I'm just saying 0, 1, 2, 3. Just start copying from 3. That's correct. But imagine now we're going to be working with large numbers, large data sets. You don't know where the second last number is. So it's a quick way of accessing it. Then we have what happens if we put the number at the end instead of at the beginning. It just means we will copy everything from the beginning because we didn't put a number there. And we will copy right up till the second last number. So in this case, if I copy everything till the second last number, I'm copying that 34, 56, 23. Why? Because the second last, I'm saying copy everything till the second last. Second last are those two. There we go. 34, 56, and 23. And the nice thing about negative numbers as well, we have the special case numbers. And I'm going to show you one. This one special case is if I decide to put a double colon and then -1, what this does for me, it reverses the set of numbers I have. So in other words, it puts it in the other order. So if I got 34, 56, 23, 50, 60, if I reverse it, I'm reading it backwards. It's going to go 60, 50, 23, 56, 34. So this comes handy when we want to, for example, sort information. And after we sort it, we just want to arrange it from ascending to descending. All right. So this output would look like this. There we go. It reverses it. Of course, we can put colon and other numbers like 2, 3, 4. That just means now what we want to step in, and we won't be troublesome with that for the time being. And then also yesterday I said we're going to do the error catching today. What happens in a program when it breaks? When we input the wrong pieces of information. So how can we fix this? We can fix this by using the try except method. The try except method allows the user or allows you to catch any errors that can happen in a program. And instead of the program just breaking, the program will move past the error, giving you a message if you input a message for the person. And the syntax for this is try to do some work, and that's why it's called to try except, because we're going to try to do this work that we got to do. And for any reason, if this work breaks, we're going to accept we're going to accept as this a reason why it's breaking and give the user a message. What work must be done if the program breaks? Now, if you looked at the sum of numbers program that we did a long time ago, we're just going to quickly create it for us. So we got number 1 equal to input enter number 1, copy that, paste it. Number 2, of course, this is a number, so I'm going to put it as integer. If we ran this program, right? And we enter the first number as 3 and the second number as 30. But if you notice that 30 looks a bit off because I actually entered 3 and a capital O. The computer will break because, or stop in this case, it's supposed to break there. The reason it didn't break, I didn't do the sum parts. And I didn't say that was supposed to be integer. All right. Quickly, let's do it one more time. 3 and 30 using an O instead of a 0. There you go. It says you that's not a valid number. Instead of breaking, we can tell the computer to move on from that. So to continue, but act like nothing happened. So we can say, all right, number 1 is equal to 0. Number 2 is equal to 0. What we do is we try to do this work, and after we try to do this work, and this work will be getting a number, we'll put an exception. An exception is, what must I say if it doesn't work? So the exception would be print the number you gave is incorrect. Just going to copy it and replace it faster than typing the entire thing again. There we go. And then I can simply say sum is equal to number 1 plus number 2. Print the sum of number 1 and number 2 is sum. So what this does now, instead of breaking the program, so if I go and put 3 here and then I go and put 3O, program won't break anymore. What it'll do, it'll try to do this work, and since it can't do it, the computer is going to give an error. And because it gets an error, it will display to you gave the wrong number, but it'll still continue with the rest of the program. But then you might be asking, how can it work with 3 and O? It won't. At the start, we told default values, so it will use the default value instead of the number you gave it. There we go. The number you gave is incorrect because that was incorrect, but it gave me the sum of 3 because that was the correct number. Please, it's the white numbers, not the blue, huh? 3 and 0. Remember, we started off with 0 for the number is 3. So instead of breaking our programs, our program can continue by catching all the small errors that can happen. And why is that important? Because in our next set of work, we'd actually needed to understand this. And that was when we used the list before. Your list that we had, remember we wanted to remove Dave the last time, and our program gave us a little error because Dave doesn't exist in this list. So what I said was, okay, my list is going to be all that information, and I'm going to print my list to show you that's there. I'm going to try and remove Dave, but before, when I didn't try, it gave me an error. So what I'm saying is I'm going to try to remove Dave. And if the computer comes back with an error saying for some reason that can't find it, then this error that the person must write or must see is Dave was not found in the list. So what this will do, it'll display Dave was not found instead of my program breaking. I got the program for us. I'm going to quickly open it up. Where is that program? Remove try. Okay, there we are. Right. Here's the program. So if I run it, and here's my output. tells me Sam, Frank, Dave was not found, and the list is still Sam and Frank. So that becomes our error catching. We can try to do some work, and that's the work I'm trying. If the program gives me an error, it can't find for some reason, here's my error. What must I do? What must I tell the person? And the error is I can't find them or do some other work. So that's the try except method. Okay, so that's how we do those try except methods. Then we move on. Okay, that was the output. To the activity, ask the user to enter in the full name and remove only the initials and surname. Assume they have one name and one surname. I did that program already, and I'm going to go through it. Where's that program again? Oh, before we do that program, there's one more function that you'll need to know before that. And the function that you need to know before that is called the strip function. You see, the strip function removes any leading or trailing spaces in a sentence. Leading or trailing spaces means if I have any spaces in the front of a sentence or if I have any spaces in the back of a sentence. And for an example, firstly, how we use this is the syntax. We have syntax, the variable that we want to save our information, where we taking it, dot strip. And the moment we use dot strip, open brackets, it would erase the information from the, or erase the spaces from the front and the back. So if we look at an example, here we have sent, and you can see over here I have spaces in the front. Okay, I got a big space there, single space, another big space, but again, a big space in the end. And the moment I use the sentence dot strip and I store it in sentence, what's going to happen is it's going to remove the leading or trailing. Leading means anything in the front of the sentence or anything in the back of the sentence. And now output for this would look like, here we go. The first time I printed it, big space in the front, still spaces there, there's a big space here. But when I use the strip function, it erased the spaces in the front, and you can see it's gone, but I still got a big space here, another big space there. There's no space here, but because I had to show you the first display, the second one looks like there's spaces, but there's no spaces in the front and the end. That's what we mean by leading or trailing. The inside spaces, it stays as is. That means it won't change. All right. So for today's activity, it was to ask the user to enter the full name, remove the initial and the surname. So for example, let me just erase this first. If I had Samuel Leroy Jackson, Samuel L. Jackson, I want to display the information for the second question. This is, sorry, I'll need to remove the S and the L. How do we know what's separating the names? Yes, there's spaces. So if you can find spaces, you can find how to separate names. That's going to be an activity for you to try, number one. And number two, I will do with you tomorrow. But tomorrow's work will also be including the start of creating our code for gaming. So all the code that you need to actually create your own little game in Python, we'll be also starting that tomorrow. All right. I hope you had a good lesson today and excited for tomorrow's one where we're going to create a game. And a little reminder, please make sure that y'all get your parents or y'all can go to the Google Docs form and fill out the participant information there because you'll be getting your certificates and the closing date for that forms is tomorrow. Do I have any questions before I end today's lessons officially? All right. If I don't have any more questions, have a great afternoon. And I'm hoping you're ready for tomorrow's gaming activity that we're going to start. I will see you all tomorrow.